Hello there and welcome to the June 2019 paper. Here we're looking at question 12. So we need to prove this trigonometric identity. It looks like the left hand side is the more complicated side to start with, so that's why I'm going to start. I'm going to start with cos 3 theta over sine theta plus sine 3 theta over cos theta. Let's create a common denominator here. So if we create a common denominator of sine theta cos theta, then on the first fraction we've already got sine theta, so we need an extra cos theta on the top, and then it's going to be plus on the bottom, common denominator of sine theta cos theta. We already have cos on the bottom, so we need an extra sine theta on the top, so extra sine theta. Okay, so let's now put this all together in one big fraction. So it's sine theta cos theta equals cos 3 theta cos theta plus sine 3 theta sine theta. Okay, so now we need a way of simplifying this denominator, this numerator here. Now the numerator looks very similar to the cos A minus B formula, that is cos A cos B plus sine A sine B, where effectively A is 3 theta and B is just theta. So on the top, this can be simplified now to cos 3 theta minus theta, and that will eventually simplify to sine 2 theta. And then on the denominator there, it looks like the double angle formula, but only half of the double angle formula for sine, so it's going to be a half sine 2 theta. On the numerator, 3 theta minus theta simplifies to 2 theta. When you've got half on the bottom of a fraction, you can effectively times it by 2 on the top, and then that's going to be sine 2 theta on the bottom. So this is clearly equal to now 2 cot 2 theta, because cos over sine is cot, and when you do it with the same angle, you just keep the angle in the side there. So that's equal to cot 2 theta, which equals the right-hand side. So there we are, that's the answer for this question here, that's how we prove it. Make sure you've got lots of detail in your steps, don't try and miss out anything. You want all the detail, every line by line. And let's move on to question B now. Hence, solve between 90 to 180 this equation here, giving any solutions to one decimal place. Okay, so what we'll spot from the link from part A to part B is that the left-hand side is wholly part A. So we can just simply write our equation in part B as 2 cot 2 theta equals 4. The first thing I think I'll do is I'll divide both sides by 2. And then rewrite cot as 1 over tan 2 theta. And then times the tan 2 theta on the other side and divide by 2, so I get a half equals tan 2 theta. Now my question here involves 2 theta. So if my angle here is between 90 to 180, then my 2 theta angle is going to be in between 180 to 360, because you double all of the parts of this inequality to get this inequality here, which nicely has 2 theta in the middle of it. So now the next thing I'm going to do is I'm going to do 2 theta equals tan inverse of a half. And tan inverse of a half gives us 26.6. Now that's not going to involve a final solution here, but the next solution on from there, if I add on 180, is going to be 206.6 degrees. So therefore, to work out theta, I'll just half this value, and that will give us 103.3 degrees. And there we are, that's the answer for this question here. That's the only solution in between 90 to 180 degrees. And there we are, that's the answer for question 12. Let's now move on to question 13.